Okay, let's look at a little more difficult subnetting scenario. Let's say you have a network here, right? And you've got a network here, a network here, a network here, servers over here, and then you have a point-to-point network with just two interfaces in between these two routers, and you're given a starting point of 172.29.0.0/22, and you need to create multiple subnets from this address space. So how would you approach that? Well, first of all, we'll look here. Here's our address space, 172.29.0.0/22. And I've written out the /22 in decimal form for the subnet mask, and I've written it out in binary. Okay, and given this IP address space, right, and I'm going to really stress that, the IP address space, given this space, creates 7 subnets. And for each subnet, here's the requirements. The first subnet needs 260 hosts, the second 177 hosts, 50 hosts, 20 hosts, and then the last 3 subnets are point-to-point networks, meaning we're only going to need 2 hosts. If they say that, you're only going to need 2 hosts in each one of these, right? That's what point-to-point network means. Okay, so the first thing to do is to figure out this address space. What is the full network address space of just this address? So if we start with 172.29.0.0, and that is the network, where's the broadcast number? Where does it end? Well, when we take /22 and put in decimal and put in binary, we see that this is the octet where we have borrowed bits, right? You can see here 11111 and then 00. So I've taken this octet and placed it up here on my binary place values chart, right? And I've placed it here, and you can see here 1 1 1 1 1 1, 6 ones, 2 zeros, and this last one is in the 4's place. That means that the magic number is 4. And if the magic number is 4, that means the networks go up by 4. And if that's the case, then the next network would be 172.29.4.0/22, let's say, right? So that would be the next network. And if that's the next network, then that means that this network goes from 172.29.0.0 to here. Okay, so that is the space that we're given. All right, so we have to create 7 subnets between 172.29.0.0 and 29.3.255, right? So we're going to carve up this space, essentially. All right, so now how do we do that? Okay, right now with /22, with a /22 subnet mask, how many hosts are in this network from 00 to 3.255? Well, we can figure that out pretty easily by looking at this example I'm going to show you right now. If this was a traditional 24-bit subnet mask, it would look like this, right? That would be /24. And in a /24 network, you've got 256 hosts, right? Every 0 that you add, the hosts double. So if it was like this, and it was /23, you would now have 256 times 2, you would have 512 hosts. Okay, and just copy that. If I did that, and I have this, right, with a 0, which is what we started with, this is /22, we add another 0 here, right? So now instead of 8 zeros, which is 256 hosts, and then 9 zeros, 512 hosts, and then 10 zeros, if you add all these, 10 zeros right here, right? 10 zeros, that would be 1,024 hosts. Okay, so right now with a /22, we've got one network. This right here is one network with 1,024 hosts. But all we need for the assignment on our first network is 260 hosts minimum. Well, we know that a typical /24 will not work because that's only 256 hosts. So they probably want a /23 or 512 hosts. So the first network we know is going to be a /23. It's going to be 512 hosts. Okay. Now the next network, 177 hosts, well, we could do a typical /24 for that because that'll give us 256 hosts, right? This gives us 512. This one will give us 256 hosts, right? For 50 hosts minimum, all we need is, let's see here, we change these to ones. And if in the last octet, if we made this, let's count the ones, /26, right? That would give us 64 hosts, okay, if we had this scenario, right? So /26 will give us 64 hosts. Okay, how come? Well, how many zeros? 1, 2, 3, 4, 5, 6. 2 to the 6th power is 64 hosts. But you could also plug the subnetted octet. In this case, this is where we've borrowed ones and zeros. Plug it into our place value system, and you can see that the magic number, the last borrowed bit, is in the 64's place. So the magic number is 64, and that tells us how the networks go up. They go up by 64, but it also tells us how many hosts in each network, right? So that's going to be /26, and then this one will be a /27, and that'll give us 32 hosts. Now, for the point-to-point networks at the bottom, the highest you can go is a /30, and that'll give you 4 hosts, only 2 of which are usable, so that'll be good for a point-to-point connection. Why is that? /30, the magic number is 4, so that means there's going to be 4 hosts in each network. You need 1 host for the network number, 1 host for the broadcast number, and now you're left with 2 usable hosts. So now you know what the subnet mask is going to be for each one of your networks, and all you have to do is start at the top and subnet each one, and I'll show you that next.